The assignment, you can submit it online. All right. So if you want, let's talk about that first. See, where would that be here? I guess would be in here. This is what should do. So assignment 1. Okay, so basically, yes, you can submit it online. Let me see what it is. Yeah, it's online. So just one thing. Remember, you need to submit it only in one file. Okay. It's extremely annoying. Personally, I don't grade them. If it's more than one file, just imagine yourself that somebody sends you your 10 pages assignment times each one of you, and you need to open every single page one at a time, no? You will be pretty annoyed, no? Yeah. Okay. So think about the grader. Talking about that, I found a grader, but he has not replied to me yet. So let's see what happens. So again, I will not be the one grading the assignments, but I will be the one grading the exams. Okay. Like I said before, I'm not going to provide you with a detailed solution. I'm going to provide you with the answers from the assignments. That way you need to go back and we work the solution, and then you can come see me if you want. Unless I see everybody, a vast majority of the class has done it wrong, then generally I come to class and do it with you, okay? But otherwise, I try to just give you the answers. So talking about now the next assignment, how can I close this? I don't want to impose anything because I don't like to impose anything, but I highly, very highly, extremely highly recommend for you for the future assignments and everything that, for example, this example that we did in class together, okay, that you have the answer, go and create your MATLAB code that will be able to solve a similar problem. Okay, I will do that with this problem, which is for a statically indeterminate, no? We need to use the two cells, no? And I will do the same thing. I think I did one statically determinated or not. In class, at the end of the day, we did two, or I will do even more for this one, okay? Take problems for which you know the solution and try to come up with your codes. And I will do that with every single problem in class, because then once you go to the assignments, at least you have something that you can compare with, no? Okay, it's very easy to do a numerical error in any of these problems. Extremely easy. And if you want, the reason here I only cover 1/4 on the VY, okay? I think if I show you the next assignment, I think that's why I had this open. I think this next assignment comes straight from Radosta's textbook or notes. So if you took Radosta's, you might recognize this one. This is actually the last problems that you solve with him in chapter 6. We do it at the beginning of the semester because we use a different approach, okay? So if you want, you can get this from him. But here, what is different and makes this problem tedious and difficult is that we don't only have a force on the Y, we all have one on the X, no? So if you try to combine both of them at the same time, 99% chance that you're going to do it wrong. Okay, so what I suggest is you do this, you first solve for one of them, let's say the VY, then you solve for this one, and then you combine the solutions. Okay, basically you add them together. Okay, so just imagine if you do already the program in MATLAB, okay, the only thing you will have to change is one variable into your MATLAB code, Vx or Vy, and you will have already checked your codes with the problems that we did in class. So basically, this problem should not take you long if you already done the work up front, no? Otherwise, this one is going to take a while. And the next problem is basically the same, but what? Statically indeterminated. So if you have the code for this one, it's probably going to help you pretty much for this one, no? Yes?
If we solve the problem with MATLAB, do you want the code in the homework, or do you want that
No, I mean, that's part of MATLAB is to check your calculations. There is no grading of a MATLAB code. Okay, but at least we know what you're doing is wrong or right, no? Okay, but before to know if it's wrong or right, you need to compare with something that we have done together in class, no? Okay, so again, that is my very highly recommendation, but I don't like to impose anything. Okay, but trust me, okay, go ahead and do it, because if you insist in doing it by hand, every time you're gonna have to restart, it's gonna be 2 hours or rewriting everything, even if you have it on the notepads. Okay, this will help you to check the calculations. All right, so before we move to the class, to the lecture today, do you have any question about the assignment 1? The assignment 1 was pretty straightforward, no? Okay, so here we go. I think I'm recording already. Yeah. All right, so today what we are doing is something that I'm sure you have done also in structures 1, which is called the shear center. I'm sure you have done that in structures 1, no? Find the shear center of open cross section. So what is the definition of shear center?
The point of force, there's no torsion.
Correct, that's pretty good. No rotation. Or torsion is the same, because torsion is due to rotation. Okay, so it would be the same thing. Perfect. So is location where the deformation of the, let's say, cross section or section does not produce, I think you said torsion, so they use torsion. But I'm going to put here slash rotation. So basically what does that mean is that the motion of that cross section is just going to be due to translation. Okay, so if you have a cross section this way at the shear center, this is just going to move up or down, and it will be no torsion, no? Yeah, just up or down, will be no torsion. So basically, in order to find the shear center, like you did in structures 1, you use the shear flows, no? What did we do in this class? We learned how to find the shear flows, not of closed section instead of open sections. So what we're going to do is the same thing. We need to take the cross section, calculate all the shear flows. And then once we know the shear flows, we can take the moments and find out what should be the point in the cross section where all the moments will cancel each other. No, the internal to external will be equal to 0. That's basically what we're going to be doing. Okay, through an example. So let's do an example here. All right, so example, I'm going to do a statically determinated for simplicity. So let's say we have a cross section here. I mean, the simplest one we can do. So with just 4 spars or 4 stringers. 1, 2, 3, 4, symmetric. So if it's symmetric, this would be the neutral axis. Let's see what we have. The total area of the cross section is 135,000 millimeters square. The area of the boom 1 equal to the area of the boom 4. So boom is the stringer, equal to 450 millimeters square, and the area of the stringer 2 equal to the area of the stringer 3. And this one is equal to 550. Okay, in this problem, they give you a bit different data over here. They tell you that the thickness of the segment 1, 2 equal the thickness of the segment 3, 4. So that's good. Otherwise, I will have to move that line, which is 0.8 millimeters. And I guess the thickness of the segment 2, 3 equal 1 millimeter. Thickness of segment 4.1 or 1.4, whatever you want to call it, is equal to 1.2 millimeters. And then we know the distance S12 equal S34 equal to 500 millimeters. Distance S23, so is the arc, would be 580 millimeters, so it should be the half perimeter. And S41 or 1.4, obviously that one is equal to 200 millimeters. Let's see, no, this one we don't need the G, so the question here is to determine the location of the shear center. Okay, so obviously we're going to use what we have done before. So what are we going to do? So I'm going to follow a procedure. It's going to be similar to the one before, but I'm going to add probably one step. I think it's one. So I'm going to go, actually it's at the beginning. Let's go this one, step 0 of step 1. Okay, what is missing from the previous promise over here? There is no shear force, no? So what we're going to do is assume a fictitious shear force that is being applied through the shear center. So step 1, assume, dummy, fictitious, whatever you want. Assume fictitious shear force acting through shear center. So if I do a figure, I like figures. Okay, I don't know where the shear center is going to be, but let's say I assume it's over here. I will assume a fictitious shear force over here. Let's say this will be our point A. And if we decide in the distance, let's say that distance here will be the location of the shear center. And I call this one E. Okay, now if we go back to what we have been doing so far all the time, what should be step 1? Now that is the shear force, if we want to find the shear flows, what do we need to do? What is it? We need to make a cut to know from where we start. Okay? So again, you can do the cut anywhere you want, but in this case, I'm going to do it. So I'm going to do it where the one that looks the more complicated, you can do it there. So let's say I make my cut between 2 and 3, so that my shear flow between 2 and 3 will be 0. Okay, so this cross section here is symmetric. So we have IXY equal to 0. We don't have any shear on the X direction, so that the expression for the shear flow, so calculate shear flows. Q of X reduces to what? To, I think, is negative. Vy is the same one we use all the time. Ixx summation of the B sub R Y sub R. What did they give you the thickness in this problem?
Yeah.
I don't know. We'll see. So there's a reason. We see. Okay, we'll find out later. No, I think I know why. Okay, so we have this now. So from this equation, let's maybe do it now. Here on a slow figure, on a small figure. Okay. All right, so if you remember here to find Ixx, the moment of inertia, how do we do this stuff? This is approximately equal to YdA, and we say this could be, this is approximated by the summation of the B sub R squared, no? We have done that enough. So since B1 equal B4, we could say this is equal to what? 2 B1, and let's call that distance HH times plus minus H squared, no? Yeah. Now we can do the same thing plus this over here, plus 2 B2 plus minus H squared. Where B1 is equal to what? B1 will be equal to 450, B4 will be equal to 450, or B2 will be equal to 550. So if you do these calculations, you find that this would be equal actually to 20, 10 to the 6 millimeters to the 4. Okay, so using that information, we know that Q23 is equal to 0. So next, what can we calculate? We can calculate Q34 will be equal to what? Q23 minus Vy over Ixx of B3 Y3. And if you do the calculations, so Y3 should be what? Y3 should be negative, no? So negative, negative, positive. This will give you that this is equal to 11 over 4,000 Vy. Again, I will recommend that you do MATLAB codes at home, no? Okay. Then we have Q41. will be equal to what? Q34 minus Vy over Ixx before Y sub 4. This one is going to give you Vy over 200. And finally, Q12 will be equal to Q41 minus Vy over Ixx B2Y2. If we did everything correct, that one should be equal to what? To Q34, no? Okay, so you do that, you're gonna get again 11 over 4,000 Vy. Okay, what is step 2 that we have been doing?
Convert to means of constant. Here, Bob.
Correct, we do the shear flows that I call Q bar, no? Plus the fictitious. So Q bar is equal to the Q plus the fictitious, no? So basically what I'm doing, if you think about it, if I do a figure, since we have time today, I'm just going to do this example. Basically what we are doing, maybe I can explain on a figure, is that
Great question.
hold on. Let me finish the figure, okay? Let me finish this. So we start here with the Q bar that we say will be equal to a Q, but because this one was open, now we assume a shear flow on the cell, no? But mentally, this is what we're doing, no? We're replacing this one by this one plus this one, no? So real problem. Yes, what's the question?
Why are we using B2Y2 for?
Oh, for the last one, it should be B1 by 1. Thank you.
Okay, thank you.
No, good question. Okay. But I mean, you see, that's what we have been doing every single time, no? Okay. So basically, it should be very easy now. So we're gonna have here Q bar 1, 2 is just Q 1, 2 plus Q naught. Q bar 2, 3 will be just Q 2, 3 plus Q naught. Q bar 3, 4 will be Q 3, 4 plus Q naught. And Q41 will be equal to Q41 plus Q naught. Okay, here maybe I would recommend, I mean, we can leave it this way. What is the step 3 that we did? Okay, so equate external to internal moments. So basically we say that, let's say we do point A, external will be equal to the summation of point A internal. So you see, always, I'm always about procedure, okay? Always try to follow the same procedure. And here I'm running a bit out of space. But let's see if I can do again a figure. So this is our point A. We say our force By was gonna go here to a point at a distance E, and we know here we have Q bar 1, 2, Q bar 2, 3, Q bar 3, 4, Q bar 4, 1. So in that figure, oops, sorry. In that figure, I want to change the notation. What would be this term equal to?
DYE.
Okay, DYE, and it will be positive, no? Okay, see, it's nothing complicated. As long as you do figures and you follow the steps, structure is not complicated, it's just tedious. I mean, and you need understanding of what is all the different stresses. Now, the internal will be equal to what? What is going to produce now? Shear. What will be the force? Q bar 1, 2. S1, 2 will be the force now. Done this enough. This is force. What will be the arm? Height H, perfect. And that one will be clockwise or counterclockwise?
Okay.
Counterclockwise, so that's positive, no? Now, you want me to go to A3 or you want me to go to another one? You want to go per order? You want to first do the other ones? 2, 3? Okay. So 2, 3. 2, 3, we don't know what it is. Because this is not really a semicircle, but we know the full area, no? They give us the full area. Yeah? Okay, in this problem. And that's what happened. Okay, I make it look like a semicircle, but this probably is more like some type of ellipse. All right. So they don't give you here the diameter, but they give you the whole thing. So really this area here should be equal to what? The whole area minus this one, no? Okay. So let's call now in our head that area A prime. And then I do a little figure, okay? So let's say here we have. So now, and this one which and that one will create a positive moment or negative moment about point A.
Positive.
About point A. 2, 2, 3, okay, positive, so plus 2 A prime. Okay, so what did we say was the moment? For this Q23, no? 2AQ. Now we go around the other ones, plus, now we do what? 3, 4, so that should be equal to what? Q bar 3, 4 times S 3, 4, also counterclockwise times H, plus Q bar 4, 1, times S 4, 1, and this time what should be the arm? Okay, S, let's say S1, 2. Yes? Okay. So let me do then maybe a little figure here. In here, I don't know what to do the figure. Because this is point A, this is confusing. This is point A. Let's say Yeah, it's confusing to call that point A here. You want us to change the name of this point? It might be easier. What is the letter that we cannot mix up too much with the A? Can we do
Z.
Z? All right, so Z. And here you can put Z then. Z, Z. Let's see, there are put this figure here, then this should be Z as well. The point Z. And now what we can say is that A is the total area. So this will be A prime. This will be A prime, no? Okay, so you're gonna have to help me because I don't have the calculations here. So let's do step by one. So maybe what is Q bar 12? Q bar 12 will be equal to 11 over 4,000 dy plus Q sub naught times S12 that we say was how much? 500. Plus 2 times A prime. What is A prime? A prime would be equal to what? The 135,000 minus what? S12 times S41. So minus 500 times S14 that we say is 200 times Q23, which will be just Q sub naught.
You forget it, term in the first,
Did I forget something on that one?
I think the height.
Oh, the height. I forgot here the height to be 200, no? No,
100.
is 100. Sorry for that, guys. It's extremely small now. This is a 100. Let me zoom in. 100. I'm not going to be able to put on one. So let's see. Let's not forget this one. This will be, no, this one is correct. Now we do Q34. So let me go to the line. Plus Q34 we say was equal to, again, 11 over 4,000 dy plus Q sub naught times 500 times 100, no? And we need the last one plus Q bar for 1. Q bar for 1 will be dy over 200 plus Q sub naught times 200 times 500. Okay. Okay, so I did MATLAB for the calculation. This is basically what I get. This is a Z, okay, over here. I'll put A again. This should be a Z. All right, internal, we get this, no? Okay, so now we have an issue because how many unknowns we have in this equation? 2. So what do we need to do?
Another equation.
We need to go find an additional equation. So almost the shear center becomes like a statically indeterminate, no? Okay, but as we mentioned, what do you say was the definition of the shear center?
That location of force supported, no rotation.
Okay, so that basically means that on that cross section, it should not be any rotation or any angle of twist. Correct? So we could say the angle of twist in that rotation is to be equal to 0, no? And that could give us the additional equation. So step 4, remember this guy, this time is to find the additional equation. And that's where MATLAB will be extremely useful, additional equation, which basically means at shear center, at shear center, no, because at shear center, no rotation, which basically will mean angle of twist equal to 0. Okay. Let me zoom out a little bit because now I'm too much. And what was the definition of the angle of twist? Was d theta dz equal to 1 over 2a, go around the cross section of the q bar gt ds. Okay, so and this needs to be equal to what? To 0, no? Okay, so if we do this in detail, this will mean what? That 1 over 2a, we go across the cross section again, another small figure here. 1, 2, 3, 4, okay. Okay, 1, 2 over 2ag will be the total area because G will be the same. A is the total area, no? Okay. And now we're gonna have Q bar 1, 2. What would be the DS between S1, 2? Between 1 and 2 would be, I think I gave you the answer, would be S1, 2, no? Now in this problem, what is tedious is what? Is that the thickness of each one of them was different, no? For 1, 2, we should then derive by 1, 2. We do the same thing for the other side. So Q bar 2, 3, S2, 3, divided by T2, 3, plus Q bar 3, 4, S3, 4, T3, 4, plus Q bar 4, 1, S 4, 1, divided by T 4, 1. And this must be equal to 0. Okay, do I need to do the step now? You need to substitute Q12 by 11 over 4,000 dy, no? Okay, Q23 by, the Q bar. So Q23 will be Q0, no? Same as before. Do we need to do it, or I can just move to the next step? You know what I'm saying here, no?
Yeah.
Do you know what I'm saying? Okay, I'm saying that basically now what we need to do is replace these ones over here, the Q bars, by these ones over here, no? Where Q12 would be equal to basically 11 over 4,000 dy plus Q sub naught. Okay. So, okay, so if we simplify this, we get 1 over 2 Ag. After substitution, we're going to get 2,005 over 48 dy plus 5,990 over 3 q naught equal to 0.
Do you have an update? Remind me later.
Oh. Okay, now I could move this one to the other side, no? Yeah. So this actually could simplify into what? 205 over 48 dy plus 5,990 over 3 q naught equal to 0. So let's see, what page should that be? 1, 2. I lost my other page. Oh, 3. Okay, so now what do we have? We have this equation here. Let's say, let's call it B. And what is the other equation that we had before? And, oh, I forgot maybe to put it. Sorry for that, guys. Sorry for that. Let's see if you can do better than me. I think it's because this. So this one, if we gave us external equal to internal, that equation will give us what? What did we have for the external? Vy times E equal to, then will be 775 dy plus 270,000 q sub naught. And let's call that equation here A. Okay. Sorry for that. Forgot that one. Okay. Now what should be step 5? I mean, generally on the solution will be what? Solve, no? Okay. So let's say using or combining, let's say using equations A and B. So let's see what we have. Vy times E equal to 775 dy plus 270,000 q sub naught. And the equation we have is 205 over 48 dy plus 5,990 over 3 q sub naught equal to 0. So can you please do for me? I'm not going to do it this time in my lab. I think you can do this one. Can you find this one? Can you find from that equation what would be Vy in function of q sub naught? So basically you need to do what? Vy will be equal to what? 48 times 5,990 divided by 3 divided by 205. Should be a negative value. Or should we do the opposite? I don't know. Hold on 1 second. Maybe we need to do the opposite. No, we need to solve for q sub naught. Okay, what would that give you? Give me q sub naughts. I don't know what to do here. Yeah, I don't think it matters. I mean, give me Vy. Now, guys, give me Q sub naught, please. Sorry for that. Now I see what needs to be done. So basically, Q sub naught will be equal to what? So give me 3 times 205. So that would be what? 615, no? Divided by 48 times 5. I'll put it here and then you do the calculations if you don't want to do them. 48, 5,990. Dy, no? Okay. Substituting into A. Again, I told you I don't have the calculations, but I have the final results. So it will give you what? Vy over E will be equal to 775 Vy plus 270,000. The value we just put over here of negative 6,615 divided by 48 times 5,990 Vy. So in here you see that you can cancel all the Vys. Okay, and everything is a constant value. And this should give you that E, the location of the neutral axis, to be equal to approximately 197.485 millimeters. I mean, any question about the procedure? Did you understand all the steps? Do they make sense? Because that's the important part, that you understand the procedure. Then the rest is a matter of calculations, no? Okay, so that would be what? One page, 1, 2, 3. All right, so I don't want to start a new example because we're not going to have time. So maybe let's do one thing. Since we started, let's see how we will do this one in MATLAB, no? Okay, let's try to do it together pretty quick together since we have the calculations. So let's see if I come over here. I don't know how I can organize this. I don't like to see the results. How can I break this in columns? Anyone? Maybe in view? I don't know. Oh, this one here. What did it do?
Oh, you mean move the command window over?
Yeah,
Arrow, the arrow that's on the window should have it.
this one here,
No, on the line with the command window,
this one here.
the arrow, yeah. Should be able to undock it and then move it to the side.
Okay. So yeah, I see what you're saying. So maybe now I can minimize this one. Is that what you're saying? Yeah. Yeah. Okay. So maybe let me do content like that. This might be the longest one. I don't think this is the result.
Just drag it to the side of the window.
This one?
No, grab it from the top and then move it to the side and then move it
To which side, right or left?
The window.
I mean, I was gonna do this. I don't know if that's what you want me to do. I'm sure there's a better way to do it. Something like that.
Yeah.
I
Basically.
mean, hopefully that will work. Okay. So let's say we need to move this. So let me, maybe I could save this, some of this stuff. But I mean, let's start from 0 and you help me, okay? So well, I cannot find the save as. Okay, probably need to do this. Home. How can I save this? I need to delete it, I guess. No. New script. Make it small. File, save as. I don't care about this one. What is this one here? Oh, I see it's another class, nothing to do with it, this one. Let me just save it on the desktop because I don't really care. Let me save on the desktop, and if we finish it, I can give it to you that way, okay? So MATLAB. Shear Center. And again, you're probably much better than I am on MATLAB, but let's see, I like to do this all the time. Clear all, CLC. Let's tap over here. Shear Center problem, and help me over here with all the data. So let's see, what do we have? So, all right, so S12 was how much?
500 millimeters.
500. S34, I think is equal to S12.
Yes.
Then we have S23 was not given, no?
It was 580.
S23 equal to 500. I don't think we need it. Maybe we need it. S41, I think that one was 200, no?
Yeah.
Okay, then we need the thicknesses. So T12,
0.8.
all right. T23,
1.
1. T34,
That's same as 1, 2.
so T12, and T41, 1.2. Let's see what else we had on the data. We had the area to be equal to 135,000, if I remember right.
That's 2.3 is 500. It's 580, right? Yeah.
The
So
what?
that's the curve.
The curve to what? Which one?
S23. S23 was I think, yeah, 580.
Okay, 580. Oh, we could have used that then. You see. Right, we do not need that. A3 was equal to this. So let's see. So let's say, even though we don't put it, let's say here, step 0. What do we say? Assume fictitious shear force Vy, because it's symmetric. So we only need the location about the X location, no? If it was no symmetry, we need to do the other one. So let's say here, symbolic Vy. All right. Step 1. Calculate shear flows Q. So maybe we can put over here cross section properties. So we had Ixx, we say was going to be equal to what? B1 times Y1. Oops, we need to change that one. Y1 square plus B2 Y2 Y3 3 4 and 4. And they will they specify the values for the B's? Oh, yeah, and it's capital B, so I need to change that. B, I forgot that on the data, B, B, and B. Okay, so on the initial data, I forgot this stuff. What is B1? 450. I think it's why is it not doing the capital? B1. Okay, I think B4 then should be equal to B1, no?
Yeah.
Then B2 is equal to how much? 550, and then B3 should be equal to B2. Then we can start moving around. Maybe here we need to put Y1 will be equal to what? S for 1 divided by 2. Correct. So, I mean, I could do this differently, but 2. This one will also be positive, no? 3 should be negative, and 4 should be negative. Okay, so maybe here would be a good stance just to stop over here. Okay, and maybe you want here to put display IXX and see what happened up to here, no? Let's see if we get the same IXX. I think I give you this value, no? 20, 10 to the 6. Okay, at least we can check this one, okay? And that's the way you have to do it by hand. I mean, I will do step by step and then I will check. So here now, calculate shear flows, making cuts between 2 and 3, so that Q23 is equal to 0, no? That's what we have. So the calculation would be what? Q12. Then this fictitious stuff is going to be difficult for me to remove stuff, but maybe you can help me. Minus Vy divided by Ixx times, what will be this one? No, we started by the other one, 2, 3, so we need 2, 3, 4, no? Is that the one we started with? I mean, guys, you're going to help me, or otherwise I'll let you do this. B3, Y3. Q for 1, maybe I could have put here Q23, Q23, Q23 equals 0. Let's do this. Whatever Q34 would be Q34, 4 and 4. And Q, then we have what? 1, 2. 1, 2 should be for 1. Minus here. Oh, this one is 1 and 1. And maybe here you can save and run. Why is not giving any value here? Oh, but didn't put the multiply. Okay, so you see 11 over 4,000, 1 over 200, that's what we have, no? Okay, so basically step 2 is assume whatever, shear flow Q sub naught, no? To make it quick, symbolic Q sub naught. And then what we're gonna have here is, maybe type it here, Q bar 23 equal Q sub naught. So Q bar 12 equal Q12 plus Q sub naught. 2, 3, 2, 3, 3, 4, 3, 4, 4, 1, 4, 1. Run. Okay, whatever that is. So, all right. Step 3, equate. Let's say M external equal to M internals about, specify that about 0.8. So I'm not going to look too much at the equation. What do we have for M external? Dy times E. So I think we need also to define E as a symbolic variable. Okay, you can put comments if you want, but I'm not going to put too many comments. Again, I'm not going to save this. I'm just going to give you this. So, and M internal was equal to what? That one I'm going to need your help. Let's see. What's that long one out here? So was Q bar 12 times S12 times what? Okay, we need to define H. Let's define H as what? Y1? No, it's the same thing, no? Is that correct or no? Yeah, I think that's H, okay. So times H, then what do we have? Plus, this time we have the 2.
2 times A prime.
So 2 times A prime, we're gonna have to define A prime. So A prime was equal to A minus S12 times S41. All right. So A prime times Q bar 23 plus, okay. Q bar 34 times S 34 times H plus Q bar 41 times S 41 times,
That's 1, 2.
I think here I did a mistake here. 41 times S12. Is that it? Am I missing anything else? That's it? Okay. Let's see if there's any error. Why is it? Okay. Okay. That's what we had before, no? That's the one we did before. Okay, so it's double check. So if you want our equation here, A should be equal to what? M external minus M internal. Whatever, this can be complicated or not. Okay. All right. Then step 4. Step 4 is at shear center, no torsion. So we have d theta dz equal to 0, no? So that will be our equation. D, I guess, was equal to what? So I can remove the 1 divided by 2GA. What was that equation? Let's see, I have it here. So we have Q bar 12 times S12 divided by T12, no? Plus,
You are 2, 3, that's 2.
yeah, I don't know if it's faster to do this or just retype it. Okay, so Q bar 23 S23 T23 34 34 34 41 41. 41. Okay. Again, I'm going to do this very quick. I have no idea if this is going to be correct. This is what we had, no? If I remember right. Okay, so we're on the right track. So at the end, what do we need to do? What did we do with that one? Okay. So then we need to do what? Yeah, so Q not so. Yeah, I don't know if it's going to do it. It was going to say it's redundant. So solve AQ B, no? For Q naught. I don't know if it's going to do it. I'm going to need your help here because I'm getting lost a little bit in MATLAB. Is that what we had? That one doesn't look familiar to me. The 41, yes, but I don't know about the other one. Oh, because I didn't do it. It was like 5, 6. Okay. Yeah. So now, how do you think, guys, I can substitute this one into the other one? That's the only one I'm not sure to do in MATLAB. Okay, so basically we do this. We're already doing step 5. Anyone knows how to do that or no? Because I think if I do it this way, if I type now AQA, I don't think it's going to do it. I don't think it's going to put the Q sub naught. You see? It's now substituting the Q sub naught by this one.
You're not using VPAs.
VPA for which one?
VPA solve.
On this one?
No, there's no, it's just one word. There's no.
Huh?
There's no parentheses.
VPA solving one?
Yeah, that's.
Okay. It replaced. See, I learned something. See, I always learn something from you guys. So now we have this. So now we can say, but why we should have another VY here, no? Did I forget something?
Well, we haven't solved for VY yet.
Yeah, but I don't need to solve for VY. I need to solve for Q sub naught.
So initial Q naught should plug in for.
Yeah, the V naughts. Yeah, I think this one, then or was the other one? What did we do on let's look at the class notes, exactly what we did. So step 1, step 3, step 5, we use equation A. Oh, we did the reverse. We use equation A to solve for Q sub naught, no? All right, so let me erase this. So we solve for this. Yeah, you see Q sub naught is in function of VA. So now we can substitute. So let's say over here, whatever, working metrics. Whatever, maybe AQA. So now we could say what? VPA, I guess. No, solve. So can we do this now? Solve this one for it. I don't know if he's going to do it. Okay, so I don't see what's going on here. Maybe we want to do too much with the MATLAB here. So let's see, what did we do on the class notes? We did.
I think we solved equation B for Q naught.
Yeah, so we solve B for Q naught.
Oh, okay. So I was going
to A.
So we solve equation B for Q naught. So that's what we did before. What is that Q naught, Q naught? Okay, so this found this. And what did we find? So Q naught equal in function of Vy. Okay. Now, so then now if I type EQA, every Q sub naught should be substituted, no? Or not?
I think so. Because
But it's not
still
substitute.
pulling in the EQA before the QO.
Yeah, but you see, it's not replacing over here, the Q sub naught.
Yeah, so you just need to redo equation A, just bring it down.
Just use subs.
Mhm.
So just tell me what to do, what to type.
This hard coded equation here, right?
Yeah, you just need to redefine.
Okay, just rewrite it.
Yeah, you gotta redefine the equation A.
Okay, so equation A is,
I think it's a function, so to do, but I don't know how to do it.
Yeah, me neither.
yeah, I'm sure this is a function, okay, but maybe this will do it. No, it's giving the same thing, so. So equation A into all this stuff is this. So that's what I need to do, no? I mean, it's not gonna be elegant, but it is what it is, okay? Let's say it will be working vector working equation. Let's see if that would work. Okay, and now we can say, so solve work for E, no? I could put E 197.4, whatever we found, no?
Yeah. Yep.
Okay, so you see that it might take a little bit to do the MATLAB, but it's gonna help you a lot, no? All right, and it's not that bad, but this is the way you should do it. The mistake you don't have to do is don't start working on the MATLAB. Okay, you start working on the hand solution, you do the calculation, you go to the MATLAB and check it. Okay, so I give you this code, I don't care. All right, but you see, it took us what, like, I mean, it took us a while, like 20 minutes, no? But we did a problem in 20 minutes. Now you can just change the data and you always have this code that would work. All right, so let me save it. Before I close it, let me make sure that I know what it is. So then, all right, so let's see, modules. Can I put it just over here? Do you want me to put it within the, or you want me to get another model? Let's get another model. In case I give you another MATLAB code, okay? So MATLAB code. File, create file, choose file, desktop. Oh, looks like, I don't know, this is it, okay. Okay, and if you want, you can use this one as a starting point to do the other problems as well, no? Okay, so now since we are here, so you're gonna have an assignment 2, which I already show you, no? Start early, start doing MATLAB codes. Next week, exam 1. When do you want to have it? So I made the assignment due on Tuesday, Wednesday. Is what? Everything we have done so far. Including assignment 2. That's why I do it right after assignment 2. I'm just going to give you the answers.
So should we maybe have to test some Thursday so we can study?
It's fine with me. You want a Thursday? I'm asking you those things, okay? Thursday, okay, it's fine. So that should be Thursday. No, not February.
All right, guys, we're at time.
So Thursday, what are we today? So the 13th? No, that's Friday. That's Friday, the 13th. So
It's still, I'd say it's still number 13, that's true.
okay, save and publish. So I mean, basically, it's not. Imagine the exam is going to be something like one problem from assignment 1, one problem from assignment 2. No, it's
So
not.
we're gonna have to do 2 problems similar to the assignments in their entirety, like.
Yeah.
Okay. A lot of calculated practice.
Yeah, but that's what I'm saying. If everything is clear, okay, you can do it. All right. Any question?
We'll have the whole class period.
You have the whole class period, yes.
No, you got 50 minutes.
I mean, I've had teachers do that.
No, you have the whole class period, okay?
We have like a 1 hour class.
I mean, guys, let me put it this way. You see that I was able to do it, okay?